Good afternoon and welcome to everyone joining us for session 3, focusing on roads. I met most of you last night. My name is Leigh-Anne. I'm going to be chairing this session. We have 4 talks that are going to take us for the next hour, and our first talk is going to be a student presentation. So we're excited to have Christie, and she's going to be talking to us about preliminary results from a resurvey of long-toed salamander use of road underpasses in Waterton Lakes National Park. Welcome.
Hi, so my name is Christie, and I am a new master's student at the University of Ottawa with the Leigh-Anne Lab, and today I'll be sharing some early results from my thesis project. So first and foremost, I would like to recognize that the field work for this project was conducted in Patos-Makassikami, which is Waterton Lakes National Park, on Treaty 7 territory, home to the Niitsitapi, including the Kainai, Piikani, Siksika, and Omskapi Piikani nations. I would also like to share with you the Blackfoot word for salamanders, which is Namski. So amphibian populations experience the highest global decline out of all other animal taxa. Many amphibian species move annually between terrestrial habitats and aquatic breeding sites, often across roads. The mass migrations make amphibians one of the most vulnerable taxa to road mortality, comprising up to 90% of vertebrate kills in some studies. For salamanders specifically, road mortality has been estimated up to 19% of the population, and with mortality rates of 10% leading to local extirpation, road mortality is a significant concern. Roads also have many indirect effects on populations, including declines in species richness and genetic diversity in proximity to road systems. So what can we do? One solution is road underpasses, which have been implemented in numerous places across the world, including Canada, the US, and Europe. These tunnels allow amphibians to travel freely underneath roads, passing from one side to the other unharmed. These systems often include directional fencing to funnel amphibians into the tunnels. Road mortality rates decrease significantly after installation, showing great promise as a mitigation strategy. However, long-term monitoring is rare, and the continued effectiveness of these systems in the face of climate change and large disturbance events is unknown. The focus of my study is the long-toed salamander. They are a species of special concern in Alberta, in part because of its patchy and narrow distribution in the province. Long-toed salamanders are a pond-breeding amphibian and undertake an annual migration between terrestrial habitat and breeding ponds, increasing the susceptibility of the species to road mortality. The species is also threatened by habitat loss, human disturbance, and recreational fish stocking. Now, I want to introduce you to the salamanders in Waterton Lakes National Park and the Linnet Lake population specifically. The population breeding in Linnet Lake is well known among locals and the province as a whole due to media coverage, its location along the entrance road, and its proximity to the town site. This population has a very rich history. The population was first identified in 1992, 2 years after construction of a sidewalk along the entrance road. One night after heavy rains, a parks employee discovered many salamanders were blocked by the new curb. It turns out, despite initial screening for the sidewalk construction not indicating any negative impacts, there was a large population of salamanders migrating between the lower slopes of Crandall Mountain and Linnet Lake for breeding. A group of Parks Canada staff and local volunteers moved over 1,200 salamanders across the road that spring. And by 1993, the park had regraded the curb to allow salamanders to surmount the curb on their own. The first study on this population was conducted in 1993 and 1994, which estimated road mortality at 10.2% and a population size of 3,865 individuals. A follow-up study was conducted in 2008, which estimated the population to be 1,492 individuals, a substantial decline from 1994. In response to this study and other reports of continued road mortality, the park installed directional fencing and 4 amphibian tunnels under the entrance road in the summer of 2008. This system was the first of its kind in a national park in Canada, paving the way for implementation of road mitigation strategies in other places and other national parks. The tunnels were considered highly successful, reducing road mortality to 0.6% by 2009. However, a follow-up study estimated a population size of 1,380 in 2013 and 706 individuals in 2014. Unfortunately, this suggested a lack of significant recovery despite attempts to mitigate road mortality. This was the last formal investigation on the population and the tunnel system. However, the results from the study did lead to this population being included in the park's multi-species action plan. Then, in 2017, the record-breaking Keenan wildfire swept through, burning 39% of the park. The fire was unusually severe, with 88% of the burn area classified as extreme or high severity. Here we can see just how extensive and severe the fire was around Linnet Lake and the tunnel system specifically. This fire destroyed the original directional fencing and dramatically altered the landscape around the lake. The fencing was soon replaced with repurposed guardrails, and salamanders were observed using the tunnels. However, informal surveys revealed a striking difference in numbers from previous studies on the population. In 2022, 5 salamanders were observed with 73 person-hours of searching, and in 2023, 6 salamanders were observed with 56 person-hours of searching. Keep in mind, this was during the peak migration period. The small number of salamanders observed raised questions as to the current status of the Linnet Lake population and the extent to which the road underpasses are currently being used. Which brings me to my objectives for this study. 1, to get a formal count of the salamanders using the tunnels during the spring migration, and 2, compare the demographics and spatial arrangement of individuals using the tunnels to past observations. To accomplish this, I conducted formal surveys during the spring migration period between April 17th and June 26th this year. I installed 2 pitfall traps at each tunnel entrance for a total of 16 traps, and I placed artificial cover objects at regular intervals along the fence. I also conducted night searches along the road adjacent to Linnet Lake to capture any salamanders bypassing the tunnels. For each salamander captured, I recorded the sex, snout vent length, and mass. I also took dorsal and ventral images on a standard grid to allow individual identification for later mark recapture estimates. And here's just a quick reminder of my first objective. So I was fortunate to experience seemingly ideal conditions for salamander movement. It was very, very wet in contrast to recent years, which were very dry. I captured a total of 24 salamanders with 20 unique individuals. 22 of these 24 captures were at the tunnel entrance, and 2 captures were made on the road outside the fence extent. I also observed a large 8-to-1 ratio of females to males. My largest capture event was 8 individuals over the night of April 26th. Now, to make comparisons to previous studies. Firstly, although I observed far fewer individuals, spatial patterns remained relatively consistent, with tunnels 3 and 4 demonstrating the highest use. These tunnels are located on the southern section of the road. Secondly, the female bias in my captures is consistent with previous formal studies. Now, during the course of my study, I came across something I really wasn't expecting. I found an individual with a visible pit tag, as well as several individuals with visible implant elastomere. These marks were actually used during the 2013 and 2014 study. The species was previously thought to have a typical lifespan of 6 to 8 years, with a maximum of 10 years based on a skeletal chronology study in 1996. However, 30% of my individuals were marked in 2013 or 2014, expanding the known lifespan of this species beyond 13 years old. These individuals also appeared healthy and in breeding condition. I now want to look at the size of these individuals. Here's data from adult females. On the left is snout vent length, and on the right here is mass. I'm showing the mean and 95% confidence intervals. As you would expect with a high proportion of older individuals, my mean snout vent length and mean mass are both significantly larger than the 2013 and 2014. And again, you can see the difference in the number of individuals. After discovering these old individuals, Dr. Cynthia Pezowski was able to send me a pit tag reader. This was halfway through my season, but did allow me to make a positive ID for 2 individuals. And here I've added lines to show you where these ladies fit in. As you can see, they continue to grow from their original capture date. So to sum up from my first field season and the first formal survey of this population since 2014, I observed far fewer individuals using the tunnels than during the same time period in previous studies. In fact, I only had 24 captures in comparison to 266 captures in 2014. However, patterns in spatial distribution and population demographics were remarkably similar. Tunnels 3 and 4 remain the most heavily used, as they were in 2014, and the ratio of females to males remains high. Now, the large fraction of previously marked individuals I captured and the increases in snout vent length and mass compared to previous studies suggest my 2024 captures may be old adults. In terms of the broader significance of my results, we often focus on populations when making conservation decisions. In the case of Linnet Lake, if the results from my full mark recapture study suggest that the population has been effectively lost, it might be tempting to focus on other populations. However, the old individuals I observed have survived a massive wildfire, landslide, fish, and a road, suggesting that they may have a stress-resistant genotype. This raises questions about the potential value of individual genotypes for the protection of the species as a whole under global change. So the Leigh-Anne lab is actually in a unique position to answer these questions, as we have genomic data from other populations, both in the park and other places in the species range. For me specifically, I plan to expand my tracking effort around the lake next spring. My captures may be a fraction still following the old migration routes, and newer recruits may be using different parts of the landscape. This will allow me to investigate migration orientation patterns and conduct a full marker capture study. So if you're interested in Leigh-Anne Lab's upcoming work, please check out our lab website. And I want to acknowledge all of those who have helped with information, the Leigh-Anne Lab for their discussions and overall support, and the organizations that funded my work. So thank you for listening, and thank you to the organizers of this conference. I can now answer any questions you guys may have.
So we have about 3 minutes for questions. If you want to manage your own, Elke.
Yeah, sure.
Yeah, that's great. I was just wondering if anybody has studied the reproduction in the lake itself, just to see if there's something happening with the larvae or the eggs.
Not recently, although the lab, one of the times that they're doing their informal studies, they did actually observe a female and a male, with the male like going after the female. So there is evidence of reproduction happening in the lake. It's just a matter of poor recruitment over the past few years, it seems.
When were the fish observed or introduced into the lake?
These are actually native occurring.
Okay.
One of the issues is because it's so close to Middle Waterton Lake, occasionally there's flooding and that brings fish in. They have tried removing the fish, but unfortunately they can't get them all. And if there's flooding, it unfortunately reintroduces them.
Thanks.
So what's the like the breeding migration? Is it like sex biased, or like is there a reason there's so many more females than males observed, do you think?
I suspect it may be because we're capturing them a little bit late. The males usually head to the breeding pond before the females. Sometimes some people even observe them moving a little bit under the snow. So yeah, we're just capturing them a little bit late, so we have a female bias.
Just a suggestion, with my tunnels in the Duncan area, I see more hesitancy with the juveniles to go through the tunnels, and they turn around and they just won't even try. So I don't know if you're doing anything around juveniles or fall work instead of just focusing on adults in the spring, but that might get to why you might have some low recruitment.
Yeah, I would like to do some extending it into the fall as well, so that we can have a broader survey period.
One more question. Yeah. So, how close is their next population of long-toed salamanders to this one?
I'm not sure the exact distance, but within a few kilometers is another population, Stable Pond. So there is some potential for migration between there. Very good.
Well done.
Okay, thank you.
All right. Next up, we've got Cayla, whose the title of the talk is Assessing the Efficacy of a Geospatial Model to Predict Turtle Road Mortality Along County Roads in the United Counties of Leeds and Grenville. Take it away.
Awesome. Thank you. So hello, everyone, and thank you for coming to my presentation today on assessing the efficacy of a geospatial model to predict turtle road mortalities along county roads in the United Counties of Leeds and Grenville. My name is Cayla Darling, and I did this project in collaboration with my coworkers Richard Berger and Catherine Black from Blazing Star Environmental. Blazing Star is a small ecological consulting firm based out of Oshawa, Ontario. We did this project also in collaboration with the Algonquin to Adirondacks Collaborative and on behalf of the United Counties of Leeds and Grenville. Perfect. So the United Counties of Leeds and Grenville are located just east of Kingston, Ontario, in the UNESCO World Heritage Site of the Frontenac Arch. The St. Lawrence River runs to the southern boundary of the municipality, and there are several parks, including Thousand Islands National Park, contained within the boundaries. In 2023, UCLG reached out to Blazing Star, asking for us to create a model to predict turtle road mortality along the county roads in the municipality. we decided that that sounded great because we really love helping out with turtle mortality stuff. And so we moved forward with the project. And for the next year and a half, we built several iterations of the model. And for the next year and a half, we built several iterations of the model and had some successes and some challenges and generated a lot of discussion around base data integrity. So the first iteration of the model was a least cost raster model. Least cost rasters are basically, they use a raster GIS file, and they rank habitat types using user-defined permeability codes, and they calculate a least cost path through raster cells. We chose this approach to account for habitat dispersal corridors and connectivity in a fragmented landscape. We use the Ontario government's SOLRIS, or Southern Ontario Land Resource Information System raster land cover data, and combined habitat types and assigned permeability codes based on the government's description of Blanding's turtle habitat. Lower permeability codes indicate more suitable habitat for turtles. We also included layers for culverts and watercourses in the model. So this was the output for the first iteration of the model. As you can see, it's quite pretty, nice and colorful. And there was approximately 5 different sort of like pathways that we calculated across the counties. We conducted road mortality surveys to validate the model and gather more occurrence data. We selected 12 survey transects across UCLG and categorized them into risk levels based on several parameters. High-risk sites were county roads that intersected with the least cost path and had existing turtle records within 2 kilometers, reflecting the general habitat description for Blanding's turtle. Medium-risk sites were areas along county roads that intersected with the least cost raster, but were not within 2 kilometers of Blanding's turtle observations. And finally, low-risk sites were areas that did not intersect with the least cost raster and were also not within Blanding's turtle habitat, or within the 2 kilometers for Blanding's turtle habitat. Each survey site was 200 meters long and surveyed on foot once a week for the entirety of the field season. We recorded live, dead, and injured turtles, as well as turtle nests, and all data was collected using iNaturalist. After the field season, we compared turtle observations across risk levels. We had hoped if the model was effective, we would expect similar observation numbers in medium and high risk sites, basically proving that the model could predict turtle occurrences outside of known hotspots. However, medium risk sites had significantly fewer observations compared to high risk sites and were more similar to low risk sites. This suggests that the model was not effective at predicting turtle observations outside of the known hotspots. So we revisited our approach. Instead of discarding the least cost raster model, we chose to enhance it by incorporating a habitat proportion and suitability analysis. This second model looked at proportion of habitat around turtle occurrences versus control sites and determined if there was a positive or negative correlation with certain habitat types and the proportions around the known occurrences. It would then project these correlations across the entirety of UCLG and determine locations that were more suitable for turtles. This twofold model would help address smaller scale habitat associations and improve predictions of turtle occurrences. We generated random points along county roads and compared the proportion of different habitats within 250 meters of each random point to that within 250 meters of each turtle observation. We then used a binomial logistic regression model to identify which turtle habitat types were positively or negatively correlated. And as you can see, there are some trends, thankfully, which is great for us. So shocker, Martian, open water habitat are positively correlated with turtle presence, whereas things like tilled, which is an agricultural habitat type, are negatively correlated. There's also some fun ones in there. So thicket swamp is quite well positively correlated, and I would love to have a conversation about turtle habitat dispersal habitat if you have the time after this. But basically, one second. Ooh, yeah, we also updated the least cost raster using this analysis. So we updated the permeability codes based on what habitat was more positively correlated, and we analyzed the impacts of road width and the association of different forest types with turtle occurrences. We also adjusted the permeability code for watercourses to prevent them from becoming superhighways. Originally, they were the lowest possible permeability, and what happened with the least cost raster was it just took those and ran with them instead of actually like considering other habitats. And so we adjusted it to be slightly less permeable so that other habitats could be considered as well. So this is what the original least cost raster looked like. And that is what the updated one looks like. So very different looking, a little bit crazier looking, but yeah, it was definitely improved. So we then combined the predictions from the habitat suitability analysis and the updated least cost raster to create a final model that considered both habitat and landscape level selection. We rated these areas based on a color gradient and a risk level. So 5 obviously is the highest risk of turtle occurrence, and it's nice and red, so you know, like danger. Perfect. And then so our risk levels, we did 1 through 5, 5 being the highest, as I said before. High was areas where the least cost raster intersected with county roads and also had a high prediction rate for the habitat suitability model. And then we're also within proximity to high traffic point counts across the county. Category 4 was areas that had the least cost raster that intersected with county roads and then also a high prediction rate in the habitat suitability model. Category 3 was the least cost raster or a high prediction rate of the habitat suitability model. And then 2 and 1 were low and medium prediction rates in the habitat suitability model. We generated this file, wrapped it all up, put it in a neat package, and gave it to UCLG at the end of 2023. And then in early 2024, they reached out to us again and asked for us to provide mitigation recommendations based on locations that the model had selected. They were going to be conducting work on 16 portions of county roads, and they wanted to determine if they could update mitigation infrastructure while doing this and also prevent any mortalities during those works. We looked at this and we're like, well, that's a great opportunity to also test the model. So we created a proposal to complete the work. These are our survey routes. So they're pretty well spread out. Some of them are interconnected, which is why there isn't exactly 16 up there. Some of them are long, some of them are short, some of them are within close proximity to known turtle habitat, some are not. So it gives us a really great kind of snapshot of the different habitats along roadways in UCLG. We then conducted surveys over 3 weeks during the turtle nesting season of this year to capture point in time of high turtle dispersal. Each route was surveyed 8 times, and we ended up getting about 156 observations out of that. During that time, we also ground truthed the SOLRIS data, so the raster data layer that we used to build the model. And we also, in our road mortality surveys, recorded dead, live, and injured turtles, as well as nests. And then we also did mitigation infrastructure surveys and recorded those so that we could provide those recommendations. All right, so this is the fun bit.
Female, so it was significantly larger.
This is the fun bit. So basically, we just after doing our analysis,
what we know about coastal populations,
literally like
our home ranges vary from.
We realized that categories 4 and 5, there was no significant difference, and because their parameters are so similar, essentially they are the same except for the traffic point counts. We decided to combine them into one category. So we compared those across all the other categories versus random points on county roads. And so just a reminder, 4 and 5 are the dual model, 3 is either model, and then 1 and 2 are very medium and low prediction rates. And so what we found was that categories 4 and 5 had over 50% chance of predicting turtle occurrence than random points along county roads, whereas category 1 had a less than 50% chance of predicting turtle occurrence over random points in county roads, which means the model is not just able to predict, at least to a certain extent, turtle occurrence, it's also able to predict where they are least likely to occur. Pretty neat. We also noticed that the category 3 was lower than categories 4 and 5, which indicates that the solo models are not as effective as predicting turtle occurrence along county roads as the combined, which is great. We also did SOLRIS ground truthing during this time and basically compared our habitat classifications to the SOLRIS definitions of these habitats, and we noticed some trends looking at percent error in particular. So I'm sure you can notice like up there, I don't know if I can use this, but anyways, not really. But basically undifferentiated, which is at the very top, has almost a 50% rate of error. Undifferentiated is essentially an unclassified habitat type. It's typically brownfields, right-of-ways, like ditches and things like that. So we kind of decided to look and see if there was a way we could maybe update the permeability code there. So when we looked at undifferentiated, we noticed that most often it was likely agriculture or built up pervious, which is recreational, commercial or residential areas in rural locations. So somewhat permeable to turtles and other taxa, but not like super permeable. And those permeability codes had agriculture was 6, built up pervious was 7, and we had given undifferentiated a 6. So there's not like a huge difference in their codes. And so this kind of gave us like a bit to think about, because basically if we wanted to update undifferentiated, we would then have to go out and ground truth all areas along roadways to get the correct classification, as it is incredibly common along roadways. There's a lot of ditches along roadways. Obviously, this is impractical. And because of the only slight variation in the permeability code, we decided that it was most likely not significant to the model's accuracy in its predictions. However, after we removed undifferentiated from all habitat types that were ground truth, we still were left with a 28.4% error, which is a very high rate of error. And there's not really any real way to fix this without extensive ground truthing. So we just kind of, we're stuck. Like we think like, oh, it would be really great to refine the model, but ultimately there's still going to be a 30% intrinsic error in this model no matter what we do. So there's several ways we've discussed changing this, one of them being investing in better base data, including LiDAR, which can be quite expensive. And obviously we're recommending that if UCLG would want something like a little bit more higher rate of like prediction, then you might need to do something like that. So future applications for this model, obviously improving it would be great. Right now, it's doing a pretty good job. It's pretty effective for what UCLG has asked of us. However, it would always be great to make it better. We'd like to compare it to other methods, such as CircuitScape, which is currently pretty much industry standard. We'd like to acquire better base data like LiDAR, and we'd like to apply it to other municipalities, including more urban areas, to see if there's any differences in its predictive power. Okay, thank you. Any questions?
Thanks very much. We have 1 minute.
Sorry.
See how many questions we can get in. This is a mic. Thank you. It's all good.
So for the counties, are they required to do that type of mitigation, or are they just being altruistic?
They're just being altruistic, yeah. So it was just like he's retired now, but he reached out to us, and his name's Jeff, and he was very like about the turtles.
So how are they covering the costs and getting engineering to buy into that?
Please
tell me. I work for a local government, and this is a big challenge.
I think they applied for stuff. So the original project we did was partially funded through A2A, which is the Algonquin to Adirondacks Collaborative. And so they got some funding that way. And then I think there was just like a little bit extra left over for this year. So this year is kind of the end really. We're completing the work that they'd asked us to do. Yeah.
Thank you.
Thank you.
That's all our time.
Sorry about that.
No. Our next speaker is Sara Ashpole. She's going to be speaking about South Okanagan before after control impact study observations a decade after mitigation.
Leigh-Anne, you're giving the talk with me. And we wore the same outfit. Leanne's like, I exit. Fantastic. So really hard for me to stay still, but I think I have to. This is one of my favorite images of the Okanagan because it reminds me that there's still natural elements in here. And I'm going to take you away from that. For most of you that have seen a lot of my talks, because I've been working in this area for about 20, 25 years, and I deal with a lot of like end of the world scenarios, I'm not off brand today. I'm just not going to talk about that. I'm going to really focus in on one thing that Leigh-Anne and I have been thinking about quite significantly about, did we make good choices in the past and how do we make good choices in the future? So I'm revisiting a project that was done by a grad student, and we're looking at how efficacious it has been. So I always like to say, like, you know, this land that I've been working on, this is Okanagan Nation, Sea Lakes people, so I've been very privileged to be there. John Cole put in 3 years intense research into this, so she still requires a lot of recognition. And there's been a good number of other individuals that have helped out. The last one being my partner, Steve Jones, who says, "Hi, Leigh-Anne." So where are we kind of at, right? We want to find out like what is the effectiveness of the mitigation strategies that we put in? Is it actually having a positive impact on road mortality? But more so, is there population level impacts that have happened that we need to think about? And in the short term, we're just asking ourselves, is the fence working? Are animals using the fence, and which animals are using the culverts to move back and forth? So this is kind of where we are at. If you're not familiar, here's North America, and where I spend most of my time, just travel about, I don't know, 8-hour drive from here, get across onto the mainland. Beautiful area. And it's a really complex area to work in, right? I mean, you've got a lot of different communities, a lot of social and economic type issues here. You go there to smoke pot and drink wine. There's really great hot beaches you can hang out in, and there's really high levels of biodiversity. And I have to say, it's been a really great place to hang out. I try to leave before tourism begins, but overall, I have to say, pretty nice place that everybody should visit. Has a wonderful suite of species, amphibians and reptiles, like really beautiful. A lot of these are adapted to desert environments. So they burrow, they understand this landscape, and they're quite good. But what I'm talking about today is, I would say that it's really limited to very few. So probably when you think about this project, should think about the endangered tiger salamander. Probably makes up about 3% of my observations. Great Basin spadefoot, probably about 60 to 75% of my observations, followed by the tree frog. And then I am damn lucky if I see a snake. And when I say damn lucky, this snake project, the road project, I have probably over all of these years seen less than half a dozen cumulatively, until we actually started doing some camera trap this year, and we actually had a few more hits. But it's not uncommon for me to go the whole season without seeing a snake, and a couple little spots with turtles. So this is just to give you an idea of what things look like. So around 1997, this image on your left shows a beautiful 2-lane highway, almost no curbs on the side, very short, you could, regular type of road. Then Whistler Olympics came and they got a lot of money, and they're like, where are we going to do a road expansion and invest in road infrastructure? And they decided to do it in the South Okanagan, where they had the least amount of conflict of stakeholders to expand a roadway to accommodate all of the increased humans and traffic. But they didn't expect to have me there. The person who said, are you aware that there is a tiger salamander breeding pond, one of only about 8, right where you're going to put this? And I blackmailed the Ministry of Transportation Infrastructure into a couple $1 million, and we went ahead with this project. And they expanded it to a complete frontage road, that's the original highway, and then 4 new lanes of highway, and took out the whole riparian landscape. And now you're talking about a fairly significant barrier that goes north-south throughout the whole valley. When we think about the area we're studying, we have actually about 50 kilometers of roadway from Penticton down to the border. I'm going to divide this into 2 primary areas. The bright blue, this is our intense area. This is where the mitigation and the road expansion occurred. But we also do road surveys throughout the main highway and down through the back Black Sage Road area. And so this area here, this is our road area that we survey. And from about 2010 to 2013, we have about 2,000 hours of survey time. There was about 4,500 observations, 55% were dead. And that's what really helped us to figure out where we were going to put some infrastructure and camera traps. That should really say 2013 to 2022. In that period of time, we were doing opportunistic road surveys. So, you just happen to be driving by and you collect data. But we were actually maintaining the fence system every single year. So we have an idea of what the condition of the fence was in, and I'll talk a little bit about that. But then I went to Leigh-Anne and I said, Leigh-Anne, I'm actually getting to be really concerned because I'm seeing nobody on the road. That's great, but I'm seeing nobody use the actual culverts. I don't think they're using it. And my own personal observations are tanking when it comes to listening and seeing breeding frogs in the area. And so she is like, oh, year-end money, Sara. Let's actually start doing camera trap data and let's start to think about how we're going to answer these questions. So 2023 and this year, we started doing camera trapping again in the culverts. So to give you an idea, this is 77 hectares of space. And we have breeding and call data and occurrence data. And we use that to try to figure out where, in fact, we should put the culverts. And if you look at the 2.5 kilometer distance there, in fact, if within 500 meters, the whole area has spadefoots. The whole area has got spadefoots. And so it was fairly challenging to figure out where exactly to put them in. An aerial, if you look on the near side here, you actually have the Okanagan Channel, and on the far side is the highway. There has been a lot of restoration work done in this area by Ducks Unlimited, by the Nature Trust, by the Nature Conservancy, by myself, Okanagan National Alliance. A lot of these wetlands are not the ephemeral type of wetland that spadefoots like to use. And while they have used them in many years, we had this wonderful period a few years ago where we got so much water that they all got inundated with fish. And so we have a significant number of our wetlands now that we had restored 4 species that are now full of non-native fish species. And so you can see on this landscape, what we really need to maintain now is ephemeral ones that dry out fully. And in some years that happens, but generally speaking, we have we have very few locations left now for breeding for species like the spadefoot. To give you an idea of our 8 culverts that we put in, so these are between 900 and 1200 millimeters, big enough for me to get into, not big enough for Leigh-Anne to get into. They're 25 to 41 meters, most of them sitting around 35 to 36 stretches of dark, narrow, you can't see the light at the end of the tunnel. And this probably is pretty challenging for a small frog that's only like the size of my fist. We put in about 2 kilometers of lineal fencing. This is the AOC Palmer. By the way, they're here today. Anybody here in the audience? No, good. And we put in 6 sets of infrared and time-lapse cameras into these culverts. And it kind of looks something like this. So the data that we looked at from last year, we used unpaid and paid undergraduate students. No AI is available to look at their camera trap data. About 20,000 photos last year. And we had a total of 12 frogs detected, and only 3 appear to have gone in on one side and come out the other side. And so this is in 20,000 plus images, this is very few. And compared to the data from 2011, 2012, where we had like 352 to 477 frogs go through, this is a significant reduction. But we also have a very small number of total images. 2024, we're doing very similar methods to 2011 and 2012, where we were taking photos every single minute, and then the hyperfire photos. So we're going to have an insane amount of images. And so we'll see what this year comes up with. For who's using the culvert, everybody's using the culvert. In fact, very few animals go all the way through the culvert. We had beautiful families of skunks go through, a few raccoons go through. We have a lot of cats. It's probably the same cat constantly we were seeing. I mean, you can tell the color of the cat, like which cats they are. Really cool to see bear. We have bears they go through. They take out our cameras, but they're nice. And then that 45 is we had a whole pile of like snakes at one location, and they're all these like little tiny neonates. And this data doesn't tell you how often we're taking the photo of the exact same individual, and so that's quite possible. Just to give you a little idea, Anybody who can identify that snake species, I'd love to know. It's possible there's rubber boa that I've seen. And there's one site where we actually have a gopher snake now living, which is like, I just love her. She's hunting, by the way. She just goes up and down the fence line, like just hunting nonstop. And luckily she doesn't cross the road. And then we have like, here's your little frog just sitting there. And you can see, like, it just looks literally like sand with two little white eyes. Okay, and then let's talk about the fence for a second. So it's now been 10 years, and we spend about $2,000 to $8,000 a year repairing it. We have replaced every single screw on it because they disintegrate and pull apart. The product within 5 years started to tension apart and degrade in the sunlight. The product is not designed to attach to a culvert, so we've got these insanely stupid jimmied sections. And in fact, we use a lot of like EDPM polymer flexible, like for people's pond liners to kind of connect things. But like this little image at the bottom right, they pop open because they're positioned in such a way that the gravity and force material to the fence is pushing down at all times. So things just pull apart. We also have a significant issue with vegetation. About 1/3 of the whole fence line is completely covered in vegetation. We've had to get in excavators to pull out a whole pile of invasive root systems that pull it up. The fence itself, only about 1/3 is in good shape and 2/3 is in really bad shape. Does it still work? It 100% works, by the way. If you repair it, there's no animals on the road. But it's like a jigsaw puzzle every single year. So ultimately, where are we kind of at? Last year's data did reassure me there's nobody using it. Like, I'm pretty sure it's very little usage, but we're going to keep pushing on. We actually know that we've got long-term fence management, and we're at the stage now in the next couple of years where we have to decide if we fully replace it or what our decisions are. So this has led Leigh-Anne and myself to really think about what management decisions do we need to make, what information do we need to find out, and what kind of response variables are needed to determine if there's anything that we're doing that's negatively affecting the population. And just to kind of like, give you an idea of what this landscape looks like, this is the aerial view, right? And so this is about 3 kilometers in length. You have the Highway 97 barrier. You've got the Okanagan Channel and Dike barrier. Both of these barriers are really hard for a small amphibian like a spadefoot or a tiger salamander to get across. You've got upland habitat, which on one side is not any longer connected to the lowland floodplains. And on the east side actually does have some connection. And then so you've got this separation. And so we've been thinking about gene flow. We've been thinking about, like where are they overwintering? What is their survivability? We've seen anecdotal belief that there's changes in, calling intensity and breeding intensity. You've got all this restoration activity here, of which is potentially no longer doing as effective a job because it's full of fish. And so the concern here is, what will our management techniques be, and how are we going to address them to actually make good decisions? So we've been looking at funding for PhD and master's projects to get back into this. And we've been exploring some new novel ideas on how to address some of these questions. And I really should say, Leigh-Anne, is there anything you want to add? Time's up.
Time for one quick question.
Yeah, go ahead, Mark.
Okay. Yeah, so excellent talk. I really enjoyed the talk. And I just was thinking, well, you did introduce at the end that you're thinking of new and novel ideas. I'm just curious, would an overpass work? Is that where we're at now, that we need to look at overpasses for amphibians? Would that be something?
I've not at all thought about an overpass, but I have thought about the structures that are at the road level. versus under the road to allow light and water and that. So I have thought about that type of thing. I'm not too sure about the overpass. Like, do you got like $20 million? 30 million? I don't even know what that would cost.
Yeah, I'm just wondering about, maybe the economics of it, given, the maintenance and everything. Maybe there's an argument to be made, or
there probably is an argument there for something. I'm not sure about the overpass park. Is that good? Okay. Anybody who wants to talk, come find me. I'd be interested in new ideas.
Thank you, Sarah.
And the last talk of our first afternoon session is by Krysia Tuttle. She is. Conservation challenges and successes for amphibians during road construction on the west coast of Vancouver Island.
Thanks, Leigh-Anne. Thanks, Chloe. Thanks, Pam, for all the AV support here. So yeah, it's been great to be here, connecting and reconnecting with people. I had a great time last night, and it's some great talks today. I'm looking forward to the banquet. So I'm Krysia. I'm going to talk about some amphibian conservation on Vancouver Island, and partly on behalf of myself at LGL, but also in part for Barb Beasley and Katie Turner with the wetland stewards for Clackawanna and Barkley Sounds, and also the Huu-ay-aht First Nation, whose traditional territory and treaty lands the project occurred on. Okay, so we're pretty familiar that humans impact amphibians in so many ways, primarily through habitat loss and road mortality. And amphibians are particularly vulnerable because of their reliance on multiple habitats, as well as their need to move between aquatic and terrestrial habitats as part of their life cycle. And no one likes to see this type of image. It makes you feel so bad. And I don't know if I could canvass the crowd. Is there anyone who's made the mistake of going out on a spring night when it's raining, and all of a sudden you see the road starting to move and you're like, oh no. And I've actually pulled over and had a nap for a couple hours to try and avoid just running over little critters. And it's a sad situation when it happens. So Banfield Road Reconciliation Project started back in 2020, or even a little bit before that. And it's a Huu-ay-aht First Nation-led collaborative project between industry, consultants, NGOs, community volunteers, and the government of BC. And it's basically a gravel forestry road that needed to be upgraded to seal coat. And anyone that has ever driven it or drove it before it was fixed, it was like a wild adventure. Like so many speed bumps, possibly a flat tire or two. You might not even get there because of flooding or bridge washouts. It was just the road was a hot mess. And so they decided to basically upgrade it and seal coat it so that the community could have a safe drive, being able to get from. So here we are on Vancouver Island. It's just north of us here. So here's Port Alberni. And then this is 76 kilometers of road that goes to the communities of Banfield and Nakala, goes through some beautiful forests. And if you want to go after the conference, make sure you take a rain coat with you, because it gets over 3 meters of rain per year, which is a lot. But that's great for amphibian diversity. So there's 8 species that occur there, 3 of which are of conservation concern. And so when this project was being developed, we came up with 2 conservation initiatives. One was salvage, also known as mitigation translocation, and the other were to put in a couple amphibian underpasses. Okay, so the first component was amphibian salvage. We needed a permit. We needed environmental monitors to do this. And it's 76 kilometers of road. It was a big challenge to basically sweep all of that roadside habitat and the road for critters before the construction crews would get in there. And so, you can see how dense the vegetation was. But when we found amphibians, we salvaged them. We either moved them to locations further into the forest or to nearby aquatic habitat, or they were held and released at the capture site. So overall, over 2 years, we salvaged over 1,700 individuals, and a couple patterns emerged. Larval amphibians, we usually were able to salvage before the sweeps, whereas terrestrial salamanders, so the ones that don't depend on ponds for breeding, were typically found after disturbance. So we'd see them emerging from the soil and debris piles. And then toadlets were salvaged off the road anytime they were near the construction site. So this just shows you a map of the main salvage areas with the most abundant spot here at Frederick Lake. which takes us into the second initiative, which was the amphibian underpasses. And this is where we sort of shift. I became a volunteer at this point, and Barb and Katie and the Hawaiian took over. And this component is called Habitat Protection and Connections for Western Toads at Frederick Lake. And so make sure we thank all the supporters, because, you know, this type of work does not occur with a lot of funds. So a big thank you to everyone involved that helped out there. And so just to set the reasons or the rationales for this, it was really focused at Western toads. So Western toads are at risk. They're listed under the Federal Species at Risk Act. Their populations are disappearing in the southern part of BC and US, and partly because they take such a long time to mature, 4 to 6 years for an adult female to start breeding. Often she won't breed in every year, maybe once in her lifetime. And so it makes recovery really difficult once population levels get low. They have a whole bunch of threats affecting them. And just the key point here is that losing toads equals losing key components of aquatic and terrestrial food webs and energy nutrient transfer across the landscape. So again, Frederick Lake was this main area, and there's under 50 documented toad breeding sites on Vancouver Island. So Vancouver Island's pretty big, under 50, that's not very many. So Frederick Lake maybe is a source population for the Bamfield area, as well as the whole peninsula there. And just to give you a little bit of background, if you don't know much about toads, a year in a life of a toad at Frederick Lake, the adults emerge in the spring, and they come down out of the forest. They have to cross a road. So Frederick Lake is completely surrounded by roads. They lay their eggs in late April, early May. The eggs hatch out within a week, and the tadpoles fairly rapidly develop. They're really abundant. The shorelines can just be swarming with them. And then they transform into toadlets, move away from the pond. They have to go back over the road. And so this next slide sort of shows you what Frederick Lake looks like, but there's just roads that go all the way around. So Barb and her crew went out and did 42 nights of surveys to pinpoint the locations where adult amphibians, so they really wanted to get at the adult females where they were crossing Bamfield Road before it was resurfaced. And Western toad are the yellow bars, and they were mainly at the north end of the lake, whereas red-legged frogs and rough-skinned newts were at the south end of the lake. So that was the location. They were like, okay, we got to put some of the tunnels and do some fixing mitigations there. This is just a few cute photos of some of the other species that are found crossing the road at night. And Barb and I also went out and surveyed for all the culverts along the road. So this is a forestry road. They don't often replace culverts. They just stick a new one in next to it. So there were over almost 150 culverts along this section of road. And we were just wanting to know what sort of structures already existed there for safe passage for amphibians that might help out. But most of them were in pretty rough shape. So they're hanging, they're buried, or they're full of debris. So we put all that together, found 2 locations to put in 2 underpasses, replaced 2 new culverts, and these were installed at key toad crossings to connect the habitat and reduce future road mortality. So this was pretty amazing to watch them put in concrete box culverts. They make it look easy, but there's so many steps involved. It's pretty neat. Then just so many volunteers put in over 450 meters of fencing, which helps guide the toads towards the underpass, and then set up some wildlife cameras to show how well they work. And here we go. Okay, so first adult Western toad using the tunnel in 2023. So here's some eyes here. And then hop over here, no eyes, hop. So awesome, I love watching that. Okay, and then here's the other tunnel that you can see has a little bit more moisture in it. So in the back pond here, hop, plunk, and off he goes. So this shows before and after, and this is kind of the thing you want to see. So before on the left is before any mitigations, before the underpasses were put in, you can see that there are Western toads all along the road. On the right, the spring of 2023, after the 2 underpasses and some fencing were put in, you can see that there were fewer adult toads on the road afterwards, which is great. Also observed, if the video works, observed and photographed tens of thousands of toadlets moving along the fences and under the underpasses. So I don't know if anyone's ever seen this, but it is amazing. The ground just moves. There's so many little guys, and it's pretty great. They actually, they definitely move into the tunnel and move out and move back in, and you can't keep track of which ones are going in and coming out, but they definitely are using them. So that's cool. And then each year we're hoping to add more fences. So Barb's out there tirelessly, looking for more funding to add fencing to sort of protect this whole section. And so to bring it back around some of the project challenges and successes. So in terms of salvage, construction during active amphibian season, really tricky. They're just everywhere. Also, the fact that a lot of the species are small, they're fossorial, some of them are cryptic, makes them difficult to find. Timing the sweeps ahead of construction is also hard. Those construction crews move fast, and you got to get through that dense vegetation. But overall success, but a huge success there. We got lots of little critters, lives saved, and moved them off the road. For the underpasses, cost is the big ticket item here. $150,000 for 2 box culverts, so that's a lot. Also, with other studies showing this too, you got to find the right location. Like, based on 2 years of studies, are you going to be putting this really expensive underpass in the right spot to benefit, adult females, but also hopefully metamorphs? And again, that dense vegetation was crazy for trying to put in fences, just so many person hours. But overall, a huge success, 2 tunnels, 2 culverts, lots of fencing. They're being used by both adults and metamorphs. The project also increased public awareness of amphibians and their sensitive habitats for the area. So a big community investment and effort. So we've come a long way. This was the original temporary barrier, 6 meters long, put at the end of the road leading right up to Frederick Lake to sort of stop people from recreating and running over little toadlets, to over 500 meters of fencing and over 50 people that have participated in the project with monitoring, promoting stewardship. It's been a really great effort. Huge thanks to everyone. So I'd specifically like to call out Andrea Lucas, who was our Hawaiian First Nation tech. She was on site every day for like 2 years, just saving little lives. It was pretty amazing. So thank you so much to her and everyone else. And I just wanted to leave you with this idea of working together. So we hope to uphold the sacred principles of Isak, which means respect, U'aflak, which means taking care of, and Ishak me Sawak, everything is connected, which are the Hawaiian sacred principles. We're glad that the road improvements will benefit the communities and to help wildlife. And working on this project has been one way to attest to another species' right to exist, experience a brief relationship with them, and engage in reciprocity. So thank you. I don't know if I have time
Thanks.
for questions.
Yeah, let's leave your last talk. A couple
Okay.
minutes.
Hi, Jade.
Hi, I'm curious about your fencing, like, kind of in regards to Sarah's talk, like what sort of maintenance do you think it would require? And then also, I know the weather's maybe a little bit different closer to Banfield versus the interior. Like, would that uphold in cold, really cold temperatures with heavy snow as well?
Well, so this particular area does not get a lot of snow to address that one, which is great. It's such a benefit compared to projects on the interior where they have to deal with, snow plowing and the buildup of snow. But on the West Coast, you do have to deal with tree fall and water. So this area, like I said, 3 meters of water, those ditches, they're like rivers when they flow. So we tried to, I wasn't as involved, I was just a grunt volunteer for this component, but Barb and Jerry were huge in setting these up, and they've trialed them and they seem to be working quite well. If anyone's seen the fences at Ucluelet and Tofino, they seem to be lasting, but they do take maintenance similar to what Sara said. But at this point, it's better to get those fences in next to the underpasses and then sort of deal with maintenance costs and that sort of thing as we go. They definitely are more, I wouldn't say flimsy, but they're big, they're staked into the ground with fabric that's dug in rather than the more plastic, whatever curved like that's all hinged together. So they're screwed in, but into wood. They seem to hold up pretty well, but it's always near the culverts, Sarah, similar to what you said. It's like hokey how they get connected and the gravel gets pushed. And so anyways, we'll see how they do over time.
One more question.
Oh. Christina.
Yeah, I just wonder if you thought about or noticed any adverse effects of diverting the movements so far, like over 500 meters of fencing. Is something that I've thought about. Maybe not toads. I know adult toads move a lot, so it may not be such a big deal for them, but for the juveniles. And another one is predation. Have you noticed any predation along the fences?
Yeah, so I would have to defer to Barb for the predation because she has all the camera data. So I mean, assuming mink and raccoon, and we can look to see if there's, you know, evidence of predation along at the edges of the tunnels or the fences where the cameras are. And in terms of, yeah, I mean, that's a tricky thing. You can't just put it in underpass without having some fencing, but I think Barb has done she's thought a lot about that and how the directional fencing rather than putting it directly along if this is your road and then just fencing along this way, kind of coming up with ways to like angle it. And so it helps some animals that are already moving up towards the forest. And there are gaps, but yeah, it is a tricky thing. You know, how much more energy does a toad use, or especially a toadlet, if it's hitting this fence and then having to, you know, go this way and then that way before, you know, crossing over the road. So yeah, I mean, really good question. I don't know if there's a good way to answer it right away, but definitely something to be. Yeah. 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 Well, and I think it's very similar to Summit Lake. Like the toads are going back and forth in the exact same area year after year. And so if you can, you know, at least push some of them under the road, it's gonna, I mean, the road out to Banfield at this point it's not a heavy traffic road, but it is likely to increase now. And because it's such an important population, maybe something's better than nothing. But yeah, good question and good point to think about. Sure.